This problem here, we are given that the angle of elevation to the top of the Empire State Building in New York is found to be 11 degrees. So that means from the ground and looking up, our line of sight creates an angle that is 11 degrees. It's often helpful to give yourself a little sketch. So just visualize. You're down on the ground and you're a certain distance away from a building. So let's call this our building right here. Again, that's not the greatest sketch, but we just need a sketch. The angle of elevation when looking up at the building is 11 degrees. And that is the angle, not from every distance. So be careful with the distance. The angle of elevation is 11 degrees when you're standing a mile away from the base of the building. So 1 mile is the length along the ground. So we can use right triangle trigonometry to determine the height of the building. So the height of the building, we'll call it H. The height of the building is opposite the angle that we're given. And the distance from the building is the adjacent side. So we know here we need to use the tangent ratio. The angle is 11 degrees. The side opposite, of course, is H, or you could call it X, whatever you want to call it. And the adjacent side is 1. 1 being a very nice, friendly number, because anything divided by 1 is itself. So we will end up getting that H is equal to whatever tan 11 is. And so in this case, tan of 11 is 0.1944 miles. For our last problem, now we're looking at a scenario where now you're not standing at the base, you're actually standing at the top of a 200-foot lighthouse. And now we're talking about angle of depression, looking down to something that is below. In this case, it's a ship in the ocean. And it tells us that the angle of depression to that ship is 23 degrees. So it wants to know, how far is the ship from the base of the lighthouse? Again, a very different sketch you will have, because now you're standing on top of this cliff, which is given to be 200 feet. And you're looking down at something that is on the ocean. So what you're trying to find in this case is how far is that object from the base of the cliff? How do we determine angle of depression? Angle of depression is always based on line of sight. My line of sight is straight ahead, or my horizontal line of sight is straight ahead, but I'm looking down at the ship. Well, there's an angle created known as an angle of depression. In this case, it's 23 degrees. Well, since the line of sight is parallel to the ground, or in this case, the water, we can use parallel line theorem and state that this angle here is also 23 degrees. It's known as the parallel line theorem of opposite angles. Not opposite angles. It's parallel line theorem of well, some people call it the Z theorem, which is if they make the letter Z, the interior angles are equal. So in actual fact, it's called the interior angle theorem. So now that we have our angle and the side length, the side that we are given is opposite. Once again, the side that is unknown is the adjacent. So once again, we have a scenario where we need to use our tangent function. It's 200 over x. Again, cross multiplying and then dividing by tan 23, we get that x is equal to 200 over tan 23. Which tells us that the ship is 471.17 feet away from the base of the cliff, or base of the lighthouse. Sorry, I thought we were standing on the cliff, just on a lighthouse.